So it's great to see so many people interested in mobile app security. This is a topic that should be of interest to everyone, every developer. It is unfortunately not a topic a lot of developers think about when they write apps. In this talk, we're going to look at some example of some apps maybe that don't adhere to the secure principles. My name is Kerry Lothrop. I'm happy I received a Microsoft MVP award this month just by focusing on Xamarin Technology. So that's the new Microsoft. I work for this company. Who can pronounce this? OK, all the Germans are raising their hands. I know. This is Zülke. They're originally from Switzerland. And not only do we have those nice dots over the U, we also are Xamarin Premier Consulting Partner. And we've been so since the first Evolve conference. And what that means is that I get to work on a lot of fun projects using Xamarin technology. Zülke is from Switzerland, but we have lots of locations in Europe. So I'm from Frankfurt, which is just a 10-hour flight from here. And actually, it wasn't so hard to get here. There was a talk on security yesterday by Alec Tucker, where he gave a really good overview of the top 10 security risks for mobile apps. And I'm going to be focusing mostly on communication today. This is something Alec left out yesterday. His session was really great. If you missed it, go watch it on YouTube when that's out. So when thinking about security, you might ask yourself, why should I care about security? Of course, the people in here working on enterprise apps, they know they're expected, they've got confidential data in their apps. And, well, you know, you don't want to get that data, don't want that data to get lost. But even the consumer apps nowadays, even the most simplest of app, has some sort of personal data, works with some sort of backend, calls some APIs. And it's a really bad idea if you don't, the users of your apps entrust you with their personal information. And if that personal information gets leaked to somewhere else, you see these security breaches like every day. There's a new, you know, the Have I Been Pwned website by Troy Hunt. There's a new breach like every other day in there with another few million accounts. And yeah, people don't like that if you do that with their data. I have a good example. I was looking at the communication my app was doing, my phone was doing, and I was looking at some apps and trying to see if I can sniff whatever it's saying. And I stumbled across this loyalty program app that's really pretty popular in Europe. And I was looking at I'm a member of this program, and I was looking at what's happening over the wire, and I saw they're using SSL. This is great. But then I saw I can read the information by basically doing a man-in-the-middle attack. We'll get to that later. And still, the app would continue working, and I could read my entire credentials. And with that, I could basically go shopping with everything I earned with that program. So a bad example, I gave them a call. They said, well, thanks. Yeah, we must have overlooked that. And that was it. I was expecting a little bit more. But now it's fixed, and you can, I guess I'm still a customer, yeah. So now, why is it particularly important on mobile? This is because these are the two options you have. Either you're on mobile broadband or you're on Wi-Fi. Those are the communication options you have on mobile. And both of these are not very secure. So it is very easy to set up like a cell phone tower. Your phone will not book into your typical provider, but will just book into whoever it's trying to attack and route all data through there. And with Wi-Fi, I know you must have experienced this. You're at the airport. It says free public Wi-Fi, and you just click on that, and you don't know is this really the airport? Who am I trusting here with my connection? And even worse than that, Wi-Fi doesn't just scan, is there a known Wi-Fi in the area, something I've connected to already? The way it's implemented is it calls out, I know this Wi-Fi, this Wi-Fi, this Wi-Fi. Is any one of those in the area? And so it's very simple to have, there's a little device called Wi-Fi Pineapple that will just answer to those requests to say, yeah, I'm the Starbucks Wi-Fi, sure. And your phone will connect to that without asking you. So this is something to look out for. When you're developing enterprise apps for the desktop, typically the connection is a lot more secure, can be trusted a lot more. But the good news, it doesn't matter how bad the connection is if you adhere to these security principles, because either the connection will then fail completely, or it will work and nobody can read what's in the middle. If you see this in your browser address bar, would you enter your credit card information there? Who would? Not many people. How about this? Who has entered their credit card information on this URL? Yeah, a lot of people. OK, that's a lot better. How about if it looks like this? Not so much. This is because there are a lot of developers in the room, and the problem is a lot of people will just click that stuff away and say, I don't care. Yeah, some error message, something about computers. I'll go for it, and I'll enter my data there. And what this means is it's supposed to be a secure connection. They're using SSL, but it's not really secure. It's the same as in the loyalty program app I was talking about. Anybody can read what's in between. Something's wrong with this certificate. So what does it look like in mobile? Is this an app you would enter your PayPal information into? They've got a lock, you know? This is, of course, it's secure. It says there. It says PayPal, trademark. So the user can't really decide, is this a secure connection or not? There's no way of knowing just by looking at your phone if this is secure. And then sometimes we hear this, yeah, oh, I'll just submit it to the store. If there's a security problem, they will just fix that. And that is not the case. The security, the review of the App Store will not look at your app security at all. And that's because they don't know what kind of data you're transporting. It might be OK to send that data in clear text, but they don't know if this is valuable data or not. And yeah, there are lots of examples of insecure apps that made it into the App Store. There was like a hacked version of Xcode going around in China, and it just injected malware into every build you did with Xcode, and hundreds of apps made it into the App Store because that wasn't reviewed with that respect. So the point is here, it is not the responsibility of the user, it's not the responsibility of whoever is distributing the app, it's the responsibility of the developer. The developer only can make sure everything is secure. So that's everybody in this audience, probably. And users are putting their trust in you. I want to take a closer look at communication. When you're doing communication from a mobile device, these are the two options you have. If you're thinking about, oh, I'll do a connection to a SQL server, or I'll do this IoT protocol, UDP something, it's not a good idea because in some networks, only these two will work. And if you're thinking about security, HTTPS or SSL or /TLS is the only way to go, if the data is of any value to anyone. Let's do the browser comparison again. We have a browser on the left trying to make a connection to the web server. It's trying to make that connection in a secure manner. What we need here is a key, or actually two keys, a public key and a private key. And these are on the web server side. And the public key is shared with the client. And using the public key, the client can send data that only someone who has the private key can decrypt. Did I mix that up? No. I think that was right. So that means we can make sure nobody in the middle, because nobody has this private key, can decrypt the data that's being sent over the wire. The problem is here, we don't really know who we're talking to. And that's where certificates come into play. So this key is signed with a certificate and installed on the web server. And well, that certificate doesn't help much by itself. But there is another authority. Let's take example Symantec. They issue this certificate for the web server. It's installed on the web server. And because our computer trusts Symantec, we can use Symantec's certificate and their key to check the validity of the certificate that's on the web server. And then we can be sure we're connecting to the server we actually want to talk to. Whoopsie. So I said your browser trusts Symantec. That's because there's a list of certificates on each computer, or maybe inside the browser also, of so-called root certificate authorities to trust. So it's a big list. As a user, you might not trust all of these in here. So there are some companies you've never heard of. There are governments in there. And all of these could potentially create a certificate that would match anyone you want to connect to. On iOS, there are 187 of these root certificate authorities. Android 6, 157. So that's a really big list. And the security you have is only as secure as this list is. What's displayed here is called a man-in-the-middle attack. I mentioned it earlier. The browser is trying to connect to this web server on the right. And instead of connecting directly, someone in the middle, maybe the person offering the free public Wi-Fi, makes the call to the web server on behalf of the browser. He gets a response, and he serves that response back to the browser. And now the browser, if everything goes right, should show you that cross-out HTTPS. It should show you an error message and say, something's wrong here. Either there is a certificate I do not trust in the browser, or it's issued for a website or a host name that's different to the one on the web server we're actually connecting to. So if you see, the certificate doesn't match, typically it could mean that there is someone in the middle trying to listen in on your communication. I want to show you how to do a man-in-the-middle attack on a phone. For this, I have prepared this phone over here. I'm going to switch channels. OK, the phone is here. It's an iPhone 6. And I've configured this iPhone. It's using here this private Wi-Fi. And I've set you can see it, OK? Set the Wi-Fi to have a proxy server, HTTP proxy server. And this is the address of my Windows VM that's running on this computer. And on here, I have a tool that's called Fiddler. It's an HTTP debugging proxy. It's usually used to look at the traffic you have in your browser. But you can also configure Fiddler to listen on a port to connections from outside. And you can also configure it to try to do a man-in-the-middle, even if it's an SSL connection, even if that would break security. So I'm going to try. Going to Wikipedia here. I shouldn't have cleared the cache. Oopsie. So I entered the Wikipedia URL, and Wikipedia is always served with SSL or TLS. And it says, oh, there's something wrong with the certificate. And a lot of people will unfortunately click continue here. OK, it's redirecting again. And in here, we can then see the traffic that's gone to there. So everything, this is the first request that was plain HTTP, and then the second one goes to the HTTPS version, but we can still read it, getting a certificate error, but we can see everything that's being transported here. So I need a volunteer now for the next demo. Someone from the audience. Because we're going to try to hack some apps, and I don't want to take full responsibility. Anyone? Over there? What's your name? Milos. Yes. I'm Kerry. Oh, the funny character didn't make it on there. The Unicode problem. Okay. Okay. Thank you, Milos. So I've got some apps installed that are a bit Orlando themed, and I'm going to clear the Fiddler log here. Maybe you can go through the apps from left to right and see what they do. So this is the local channel, Fox channel here. You can just allow anything. And this is a good example. This behaves like we saw in the web browser, only that it's better because the user can't make a dumb decision here. So it's being very explicit too. You could also say connection not working, but this says, yeah, there's really a certificate error, something's wrong, and this is how it should behave. So okay, let's have a look at the next app. Oh, let's look here in Fiddler. We see, yeah, we can't read anything. It always says connection close, and nothing really happened. So the next app is Orlando Magic. And it too behaves as we would expect. It says authentication failed. It doesn't really say there's a certificate error. So let's look at what the Fiddler communication is. We see there are some plain text requests here to some JSON file, okay, and we can use Fiddler to format that nicely for us. And this is information that anybody can read. You know, you don't have to be in possession of the phone. You just have to be somewhere in the network in between. Let's see if there's anything of value in here. So we see an API key. Huh? What's that doing there? I don't know if this API key is of any value. Another key. Now this looks interesting. Ticketmaster API key. So I looked at the Ticketmaster API documentation, and it said you have 15,000 requests per day. So I wonder what would happen if I said like 15,000 requests there. Would the app break for every user? I don't know. Or what would happen if I returned a different URL here? So people would buy their tickets not on Ticketmaster.com, but on my website, which would be nice, actually. OK, I'm going to clear the list here again. Let's try the next app. This is called Where to Eat Orlando. If you don't know what to do tonight, you might want to check it out. So, and this is, anyone notice something? There is a nice Xamarin logo on the bottom left. So what happened here? Let's look at the log over here. We see there's communication here. Let's look at raw. But for some reason, it says HTTPS, but we can read it. So this is what's happening is just what I told you about in the first example. Someone is in the middle, the traffic is being intercepted, but the app doesn't have a clue that that is happening. There's an image view here, so it seems it's loading the background images here. And what I've done, I set up Fiddler with an autoresponder, so whenever this particular URL is called, the Xamagon PNG file is returned instead of what was actually requested. And that's why we just broke the app or changed the content for the user, even though they were using SSL. And they chose to intentionally disable certificate validation for this to work, for some reason or other. Typically, you're in testing, you've got a staging server, there's no real certificate on there, we'll just disable it, and then before we ship, we'll be sure to remember to enable it again. Okay, let's look at I'll just clear this again. Look at the last example. So this is the Xamarin Evolve app. It's a fresh install. Maybe you could enter some dummy data into there. Oh, you don't have an image for that one. Okay. Go sign in. No, go ahead. Sign in. Unable to sign in. Okay. Let's look at Fiddler. And the interesting thing here is there some hockey app, Gravatar, that was trying to get the picture for that funny email address, something Apple, but the communication is not here. But the app is still working. Well, it's not. If you were to enter your real credentials, you could log in. It actually tried to log in, but it didn't work. What happened here, the Evolve app is using HTTP client in the standard way, new HTTP client, and this is a complete re-implementation of the entire HTTP stack, and it circumvents the entire operating system. So the proxy I set on the phone is being ignored completely. If you wanted to tunnel it through Fiddler, you would have to set the proxy server in code. If it's your own app, that's easy to do. Okay. Well, you can give the phone back later. Okay, thank you, Milos. So, this is another good example of a man in the middle. Have you heard of Superfish? Yeah, okay, Lenovo's, the partner of Lenovo was called Superfish, and they thought it was a good idea to enhance all users' search experience when using Google by injecting ads into the Google page. So you search for something, and Google returns a response, and the software pre-installed on each Lenovo notebook will just inject something into there. And then Google did a switch to HTTPS, and their whole business model collapsed, or Superfish business model collapsed. So they thought it was a great idea to install a certificate authority onto each Lenovo laptop using the same key with a private key that was encrypted with the company's name and intercept all traffic. And the only way you could notice this is if you looked at the certificate information, it didn't say issued by someone you trust. It would say this, issued by Superfish. And it would say that with all sites you visited. And so someone saw this and noticed there was a root certificate installed by Superfish. And there was this certificate authority, and you could just extract it. And basically with this, you could intercept traffic from all Lenovo notebooks without them noticing, or just noticing like this. And so that was a really bad idea. They shipped an uninstaller for that, but it got them really bad press. When looking at mobile, we can do SSL, TLS the same way. We can just, like the browser did, do it like that. This would be the equivalent of, I've got the green lock there. But what we can also do is this. Roll your own CA, have some certificate on there that your phone would never trust by itself. This would look like this in the browser, but it's actually more secure than relying on this big list of root certificates. In the app, you can say, I only want to trust certificates issued by this one CA with this fingerprint, with this public key. Any other CA, I will not trust, even if it's Symantec or any other. And this is called certificate pinning. You pin a certain certificate or a certificate or authority to your app and only allow connections from that. In .NET, you usually do this with a server certificate validation callback. You just do it statically once for the entire app. There's no good way to do it per call. But whenever there's a certificate check, a certificate has to be checked, this callback is called, and you will get the chance to look at the certificates, look at the chain, any errors, and decide for yourself what you want to do with that. So the Where to Eat Orlando app had returned true here. Any error that would ever occur, completely ignore it. Don't do that, but you can do some check in there. I want to show this. I've got a little example set up. This is making code that's instantiating an HTTP client and making a call to a steakhouse here in Orlando, it's Morton's. And they've got, this is the wrong example, they've got a website, and they have port 443 also open. But clearly, they don't want people to connect to it, because let's look at the certificate here. Details. Authority invalid. Let's look at the certificate. Up here, it's supposed to be a chain of certificates, but there's only one. So this is self-signed, and it's expired like 2 years ago. And this is, no web browser user should say, OK, here, I want to continue. But for our purposes, we can actually do that. So I'll start an example here. Let's do this request on the Android emulator. Which is somewhere here. OK, there's a button, make HTTPS call. I get an error. This is the expected behavior. OK, let me change the code now. Up here, I'll globally say in, where's this? In onCreate, I'll say service point manager, define the callback, and in the callback, I'll extract the certificate from the parameters here, get the public key string, and if this matches this funny this magic string inside my app, the public key, then I will say this is a good connection. So I'm pinning to the server certificate itself, not the certificate authority, but it's a good example. And this is not a magic string inside my app that is of any value to anyone. This is the public key of the web server. If this gets stolen, so what? I can just ask the web server what the key is. And if I change it, I'm only breaking my own app, not anybody else's app. So it says here, make HTTPS call, and I get the same error again. I can't believe they changed their certificates between me implementing this and let me just try it one more time. It should have said OK. OK. Name resolution failure. Oh, this is odd. OK, it can't find www.mortons. It did say certificate error before, OK? Didn't it? OK, I don't know what's happening here. Maybe some Wi-Fi problem. But you get the point. So it was supposed to say, OK, I trust this certificate. Even though the certificate is self-signed and expired 2 years ago, this is more secure than entrusting the certificate checking to the operating system. This is something new with iOS 9 I want to talk about. It's called App Transport Security. With iOS 9, they introduced that the app can only make connections using HTTPS and only using the latest standard TLS 1.2. This is the default. If you see an error, ATS error at runtime, you have to know this. You can add exceptions to your app, but you shouldn't. It would be nicer if you could fix the backend. Sometimes you can't fix the backend, or there's a clear text resource you want to access. then you have to put it into the info plist and just make an exception for that one. This is ignored by the Mono implementation. So if you use the default Mono HTTP client implementation, you don't have to care about this, but we'll look at some options later. Because there is not just one HTTP client. There are many. And the newest Xamarin iOS 9.8 release introduced this option here. You can select to use the default implementation or Apple TLS, which does a p invoke into the Apple implementation. This is still the standard HTTP client. Or you can use an HTTP handler that is based on one of the native APIs. CF Network is the old one. The newest one is NS Session URL. So that's iOS. For Android, there is also a new one with the newest 6.1 release. Android Client Handler also uses the native API and will also do TLS from Android 5 onwards. And then there's Modern HTTP Client by Paul Betts, which basically wraps that for both platforms. It might not be needed any longer now that Xamarin has increased their support, but if you're still on the stable channel, you can use a native modern HTTP client to get a native handler on both platforms. This is an overview. So we saw proxy settings being used. The default Mono implementation ignores that completely. The native ones obviously honor the native proxy settings. TLS 1.2 support, native, yes. Mono, only iOS so far at this point. But there is a complete managed TLS 1.2 implementation being worked on. I think it's under review right now. That's going to be available sometime soon. So ATS restrictions we saw before. This is only an iOS 9 feature. Doesn't apply to Mono. It applies only to the native implementations. And if you want to do certificate pinning, you're stuck with Mono. If you want to do it the easy way, the way I showed you in .NET, if you want to do it natively, you have to do it the hard way. With native APIs, I think on iOS you have to install a certificate in the keychain and check against that, so it's a lot more hassle. And instantiating from a PCL, you saw the dialog before on iOS. You can select the HTTP handler default, the default behavior. Whenever you do a new HTTP client, it will just choose one of the native ones. On Android, that is not supported yet, but will be supported in the next release. Cycle 7 will have an environment variable you can set to set the HTTP client handler, and they're also working on a GUI for that to set that handler. I want to talk a little about APIs. We talked about the mobile side of things, so now we're connecting to someplace. And we have a lot of customer projects where we hear things like this. Oh, we've got a web service. We created it for our web server, and everything will be fine. And then the next question is, which IP address are you going to use to connect to do your requests? And we're like, OK, any IP address in the world, will that be fine? And then they say, ooh, you will need to use username, password, or client certificate. And the reason for this is that the API is implemented in a way that they don't really trust anyone to use it. So they want to make sure that only their code is using it. And that is typically a pretty bad idea. The users, the creators of these backend APIs sometimes make it pretty easy to misuse. Who here knows Parse? A lot of people. It's a backend as a service provider bought by Facebook, and they're closing down next January. This is the documentation from the Xamarin Component Store. It says, initialize the client, your ID, and your secret. So the naive way to implement this is hard code your key into here, and you'll be fine. And in fact, the university in Germany, University of Paderborn, they did an analysis of apps in the Android store, in the Play Store. And they looked at the data that was in there, and they found they could access like 100 tables on parse. The least they could access was always the users table, containing a list of validated email addresses. That's the least they could get at. And typically, they did an analysis of the code, static analysis, and they also did a dynamic analysis. And they typically could have read and write access to all tables in the back end. So all users of the app, all mobiles had the key to access anything on them. It's a really bad idea. And they could find car accident information, pictures, contact data, and even the bad guys who are writing malware use parse as their backend, so they could access that information too, like the credit card information they caught from some other apps. This is what I want to get at. If the credentials are of any value, they should not be inside your app bundle. If you look at the example, it's hard to understand how that's going to work. But there have to be more APIs after this. You have to be able to create a user and use that user to access some data that's specific to him. Don't just use this magic key. This key should be of no value to anyone if it's inside your app bundle, because anything that's in the app bundle can be extracted. Most users of the parse example, or the developers, always put it in plain text. Some encrypted it, some pulled it in at runtime, or hid the key inside the last pixels of the image. But whatever they did, at some point, the app had to access this API and put that key right there. It was in memory, and it's very easy to catch. So what I want you to think about is not trying to authenticate your app. Your app is not what is of value. Try to think about authenticating your user. It is the user that should be able to access some resources. You can revoke a token you've issued to the user without a problem if you see it's being misused. If your API key, your global API key gets lost or misused, there's no way, you have to pull your app. There's no way you can revoke that. If you get something user-specific, store it in the device's secure storage. So you get a token, an OAuth token, something like that, put it into the secure storage that the device manufacturers offer. You can use Xamarin Auth for that. There was in the training classes, there was an example with that. Or if you want to make it a little more secure, use the native APIs for that. Websites have working security. There is no reason to identify the web browser. You identify the user that's using your service. Why should the app be any different from this? Why do you want to authenticate your app? You want to authenticate the person using that app. Just think about when you design your API, think of it like a website. Username, password, you get a token. That's a cookie on a website. Maybe that's some other token with an API, but basically it's the same. And if you do have an API that wants this magic key, don't call it from your app if it is of any value. Call it from your backend. We had a project recently where we're using flight data backends. We need up-to-date flight information on flights. And each call to the API costs 1 cent. So it doesn't sound like a lot, but we were not going to put that API key inside the app because anyone could really take that key and make as many calls as they want. Even if they don't want the data, they just might want to hurt us and increase our credit card bill. So we put it in the back end, and we have more control over what we do with this API key. We can introduce caching. If he does the same call twice, we'll just do it once. We can just limit his requests. If he does it 10 times per second, we'll just throttle him and just return an error. So you get a lot more control and a lot more security. And if one of your users is misusing that, you can just revoke his token and you can't revoke this API key if you have an app out there. The last thing I wanted to show you, this is not much network communication anymore, but static code analysis. I will switch over to the other computer again. This is a cloud service called Codified Security. Here, this is the website access, but you can also integrate it into your CI build. And I log into here. So, and I did a scan of some apps that are out there. What I had to do to get this for Android is paste the Play Store URL into the service, and they did the full analysis. So I tried the Xamarin Evolve app. Sorry about this, James Montemagno, if he's here. And this does a static analysis of the code, and it works with Xamarin also. So we get a few issues in here. The important thing to remember is these are not necessarily real issues. It is up to the developer to decide if this is really an issue or not. Sensitive data means, let's have a look in here. Okay, some URLs, Azure key, Insights key. I don't know what happens if you lose your Insights key. Is that a big problem? I don't know. What can you access with this Azure key? Well, James tells me all the important keys are in the back end, just as I suggested earlier. And I didn't look further into this. But usually the developer knows right away, oh, this is a bad idea that this is in here. Okay, some password from Azure Mobile Services. Evolve, client's portable, lots of passwords. So I can't judge this, but it is something to look into. So here's another example. The web viewer ignores SSL certificate errors, just what I was talking about before. For some reason, Azure Mobile opens up a web page and ignores all errors. They might have had a reason. They must have had a reason. We don't know what it is, and it's something to investigate. Possible SQLite injection. Yeah, okay, some queries. It doesn't know what these queries are. Sometimes it's just like this, SQL. It doesn't analyze any further if there could be any non-wanted input in there. But this is something to look into. So service is called Codified Security, and that's also something you can look into if you want to increase your security. So what we see now, basically pretty easy ways to look at your own app, see if your app has any obvious errors. Anything I did just now can be done by any attacker. It is very, very easy, as you saw. And I want you to think about your app's security. Try to think in the mindset of someone who would want to attack you. Look at what your app is communicating. Look at the source code. It doesn't take much to see these things. And yeah, I think we're out of time. It's like 30 seconds left. If you have any questions, you can come up here, contact me on Twitter, and I'll be hanging around here the rest of the day also. Okay, thank you very much.